Good morning, friends. In last period, we have seen the equations regarding the potential energy, kinetic energy, and the total energy. Today, we are going to see the special cases for energy of S.H.M. Friends, I have written on the board so that it will be very easier for you to make the notes. Here, we have studied the formula for the potential energy is a half k square. Formula for the kinetic energy is a half k into bracket e square minus x square, where a is amplitude, x is the displacement. Total energy is the sum of potential and the kinetic energy, that is total energy is equal to half k a square. Friends, we can modify this formula in the different way by putting k upon m is equal to omega square. So k is equal to m omega square. So what is the formula for the potential energy? Half m omega square x square. Remember, these both formula are the same. Friends, again the formula for the kinetic energy, half m omega square into bracket a square minus x square. Total energy is the sum of potential and the kinetic energy. So the total energy is equal to half m omega square x square plus half m omega square a square minus x square. Now here onward we are going to see some special cases. Case 1, if x is equal to 0. So x is equal to 0 means this potential energy will becomes 0, and here x is equal to 0 means the energy will become half m omega square a square. So what we can say when x is equal to 0, friends, here I have plotted, we have to plot the graph of the energy against displacement. So if x is equal to 0, in that case the total energy is a kinetic. So when x is equal to 0, then the energy will be the ke. So here is the kinetic energy. So kinetic. So what we can say, at the point x is equal to 0, the total energy is pure kinetic. So this is a case 1. So based on that, at the central portion x is equal to 0, we are written the ke. Friends, how it is a kinetic energy? You can observe that potential energy will become 0. So the total energy will be the purely kinetic at mid position. Now case 2, if x is equal to a, capital A is the amplitude. Friends, you can substitute in the place of x as a, so the equation will become potential energy here half m omega square a square, half m omega square a square, and here a square minus a square. So this a square minus a square is 0. So half m omega square a square, that is the total energy. So at x is equal to a, the total energy is the potential. You can observe the potential energy is there and the kinetic energy is 0. So at x is equal to a, the energy is the potential. So we can plot the graph in this way. So here is the potential energy, here is the potential energy. So based on this graph, we can draw a conclusion whether the particle is at the mean position or extreme position. In both the cases, total energy is a half m omega square a square. It will indicate that if the potential energy is increasing, and the kinetic energy is decreasing, but the total energy will always remain constant. That is a very important conclusion. So here we have seen the two cases. In the case 1, we have seen that x is equal to 0. When the x is equal to 0, then we are getting the total energy as a half m omega square a square. So at the x is equal to 0, the total energy is pure kinetic. At x is equal to a, here we have seen that the kinetic energy is 0, but the potential energy is present. So at x is equal to a is for the extreme position. The total energy is pure potential. So this is the potential energy. Remember, if kinetic energy increases, then potential energy will decrease, but the total energy will always remain constant. So these are the case number 1, case number 2. Now case 3. Case 3, we have to see that if the potential energy is equal to the kinetic energy. If both the energies are same, what will happen? So what is the formula for the potential energy? Half m omega square x square is equal to the kinetic energy. half m omega square into bracket a square minus x square. So if you observe this, half m omega square will get cancelled out. So the next step, x square is equals to a square minus x square. Then we have to take x square plus x square is equals to a square. So 2x square is equals to a square. So x square is equals to a square by 2. X is equals to plus minus a upon root 2. Friends, I am going to explain the case number 3 once again. What does the case number 3 says? If the potential energy is equal to the kinetic energy, then we have to use a formula half m omega square x square potential energy, kinetic energy, half m omega square a square minus x square. So half m omega square will get cancelled. X square is equal to a square minus x square. Then it will become twice x square is equal to a square. X square is equal to a square upon 2. X is equal to plus minus a by 2. So friends, we can say that if the potential energy and the kinetic energy both are the same, at that time the displacement of the particle is equal to a upon root 2. For MCQ type of the question for the CET, JEE and the NEET examination, the question may be asked that if at which position potential energy and the kinetic energy are the same. The options are x is equal to 0, x is equal to a, x is equal to a upon root 2, x is equal to a square. So the correct answer is x is equal to a upon root 2. So this is a very important condition. So when both the potential energy and the kinetic energy are the same, the displacement of the particle is equal to plus minus a upon root 2. Friends, now we are going to see the case number 4. In case 4, we have to take that if the displacement x is equal to a by 2, means the displacement of the particle is equal to half of the amplitude. So what will happen regarding with the total energy or potential energy and the kinetic energy formula we know, there we have to substitute. So here, what is the formula for the total energy? Half m omega square x square plus half m omega square a square minus x square. In the place of x, we have written the a upon 2. So the total energy is equal to half m omega square a square by 4 plus half m omega square a square. In place of x square we can write the a square by 4. So here we can write total energy is equal to 1 by 8 m omega square a square plus 4 is the 4 minus 1 3. So we can write half m omega square 3 a square by 4. So if we add here, so you can get the total energy is equal to 1 upon 8 m omega square a square plus 3 by 8 plus 3 by 8 m omega square a square. So this is the part regarding the potential energy and the kinetic energy. If we can add this, we are getting the total energy is equal to 3 plus 1 4 by 8 m omega square a square. So the total energy is equal to 1 by 2 m omega square a square. So this is the important formula which you are derived. That if x is equal to a by 2, what is the total energy? Half m omega square a square. But friends, if we want to write in terms of the percentage, then we can say that this is a 25% and this is a 75%. Half m omega square a square is the energy, or the total energy formula is half m omega square a square. So if we divide with the half, here we are getting 1 by 4, and again here we are getting 3 by 4. So friends, here at x is equal to a by 2, the total energy is equal to half m omega square a square that we have derived. At the same time, remember one important condition: when x is equal to a by 2, then the ratio of potential energy and the kinetic energy is here 25 and here is a 75, so 1:3. That is also very important case. So remember, such kind of the questions are asked for the MCQ types. So we have seen the different cases, that x is equals to 0, x is equals to a, x is equals to a upon root 2, and x is equals to a by 2. So these are the total important conditions which we have studied regarding the energy of S.H.M. So friends, I hope you have understood this point. Try to make the notes properly, and remember the whatever part I am saying regarding the MCQ, that is very important, that is asked in the different examinations. Thank you. Have a nice day.